Example 5.3. Solve the system equation x plus 2y minus 5z equals 7, x plus y minus 2z equals 5, 2x minus 3y plus 11z equals 0 by Gaussian elimination. First, we write down the augmented matrix. The first row is 1, 2, minus 5, 7. The second row is 1, 1, minus 2, 5. The third row is 2, minus 3, 11, 0. For this augmented matrix, we find that the first non-zero entry in the first row is a 1. This happens to be a leading one in the first row. We then need to create 0 below the leading one. Let's try to create a 0 in second row, first column. We can achieve that by using first row times minus 1, then add it to the second row. Then 1 times minus 1 plus 1, you get 0. 2 times minus 1 plus 1, you get minus 1. Minus 5 times minus 1, you get 5. 5 plus minus 2, you get 3. 7 times minus 1, you get minus 7 plus 5, you get minus 2. Next, we are going to create a 0 in the third row, first column. You can do that by using first row times minus 2, add it to the third row. So 1 times minus 2 plus 2, I get 0. 2 times minus 2, I get minus 4. Minus 4 plus minus 3, I get minus 7. Minus 5 times minus 2, I get 10. 10 plus 11, 21. And 7 times minus 2, get minus 14. Minus 14 plus 0, get minus 14. After we have finished the first row, now we move on to the second row of the augmented matrix. The first non-zero entry in the second row is negative 1. We need to create a leading one in the second row. You can achieve that by multiplying second row by minus 1. Then the second row becomes 0, 1, minus 3, 2, while the first row and third row remains unchanged. And we have created a leading one in the second row. We need to create 0 below and above this leading one. Let's try to create a 0 in third row, second column. We can eliminate minus 7 by using second row times 7, add it to the third row. Since the third row is a multiple of second row by minus 7, therefore, after the second row times 7 add to third row, we find that the third rows are all 0, while the second row remains unchanged. We then proceed to create a 0 in first row, second column. You can achieve this by using second row times minus 2 added to the first row. Then we have 0 times minus 2 plus 1, you get 1. 1 times minus 2 plus 2, you get 0. Minus 3 times minus 2, you get 6. 6 minus 5, you get 1. 2 times minus 2, you get minus 4. Minus 4 plus 7, you get 3. Next, we move on to work on the third row. Since the last row are all zeros, there is no chance to get any leading one. So we stop the process. The first row of the augmented matrix says that 1 times x plus 0 times y plus 1 times z equal to 3, which also means x plus z equal to 3. The second row of the augmented matrix says that 0 times x plus 1 times y minus 3 times z equal to 2, which also means y minus 3z equal to 2. The last row consists of all 0, which means that 0 times x plus 0 times y plus 0 times z equal to 0. This equation tells us nothing, except there are solutions. Notice that there is a leading one under variable x, and there's a leading one under variable y, but there is no leading one under variable z. This means that z is free. Therefore, the solution of this system of equation is x equal to 3 minus z, y equal to 2 plus 3z, and z is free. This means that z can be any numbers, and x and y just follow. For example, if you put z equal to 0, then x will be 3, y will be 2. Since z is free and z can take any values, therefore, there are infinitely many solutions. The system is consistent.